Okay, following on from the quadratic formula, we're now going to look at a lesson called the discriminant. Now, the discriminant, as you can see listed in the title there, is actually a part of the quadratic formula. So there is the quadratic formula, remember? Minus b plus or minus the square root of b squared minus 4ac all over 2a. Now, the discriminant is a part within this formula, and it's this part here, b squared minus 4ac. So d, the discriminant, is equal to b squared minus 4ac. Now, what we're just going to justify now is why this thing called the discriminant, b squared minus 4ac, why is it important and what function does it serve within the quadratic formula and in relation to parabolas and curves. Okay, so we've done some work with the quadratic formula. Now, when we've worked with the quadratic formula, what we've found is that the thing splits up, and generally speaking, we've ended up with two answers. Now, what causes that to be the case is this bit here, this plus or minus. So we might have ended up, for example, at a scenario in which we had, for example, minus 3 plus or minus the square root of 16 over 2. So the square root of 16 is 4. So now we've got minus 3 plus or minus 4 over 2. So then you would do minus 3 plus 4 over 2. And then minus 3 minus 4 over 2. And then minus 3 plus 4 is 1, 1 over 2 is 1 half. And then over here you would have got minus 3 minus 4 is minus 7, then minus 7 over 2 is minus 7 halves. Now the key thing being is that we ended up with two answers. Now how did we end up with two answers? It was because this plus or minus bit that generates the two answers. Now I want you now to think about a scenario in which what would happen if this bit in here held a value of 0. Would we still get two answers? Let's just investigate that just now. So let's write that formula down again. X equals minus b plus or minus the square root of b squared minus 4ac all divided by 2a. And let's envisage a scenario in which the bit in here that we're calling the discriminant, let's say it holds a value of 0. Now let's just plug in other numbers for here and here just to see what would happen. Okay, so let's say then that we had x equals minus 5 plus or minus the square root of, so we're saying that this bit is 0 over, let's say that that would be then 10. Okay, so the square root of 0 is 0, so what we've got now is minus 5 plus or minus 0 over 10. We would then split the thing up, and you would have minus 5 plus 0 over 10, or minus 5 minus 0 over 10. Okay, so minus 5 plus 0 is still minus 5. Minus 5 over 10 is minus 5 over 10. That's just minus 1 half. Over here, minus 5 minus 0 is minus 5. Minus 5 over 10 is minus 5 over 10. Simplified down, and it's minus 1 half again. Now, the key thing is what you'll notice this time is that we get the same result. Now, we did get the result twice, but it was the same result. Now, what's happened there is the plus or minus bit hasn't created any divergence, and by divergence I mean two different answers. And the reason being is because this bit in here was 0, and this bit is called the discriminant. So what happens then is that when this bit called the discriminant in here, when it's equal to 0, when the thing splits up, you only get one answer. So it appears that when d equals 0, what that means is that you get one answer. Now let's not forget at this point, what do these answers mean? Well, we've covered this quite a lot. These answers are your roots where you cut the x-axis. So when we generate our answers from the quadratic formula, that's the roots where it cuts the x-axis. So what we've seen then is that when this bit in here is equal to 0, you end up getting the same answer, so you just get one answer. So what does that one answer mean? That really means that you get one root. Okay, right. Now, let's now investigate a scenario in which that number that we're calling the discriminant holds a positive value. So let's say it held a value of, say, 16. Okay, and let's put in any random numbers in here. So let's say it was minus 2 plus or minus the square root of 16 over 4. Okay, so the square root of 16 is 4, so that would be minus 2 plus or minus 4 over 4. We would then split the thing up, and that would be minus 2 plus 4 over 4, or minus 2 minus 4 over 4. Okay, so minus 2 plus 4 is 2, 2 over 4 is 2 quarters, that's 1/2. Minus 2 minus 4 is minus 6 over 4, and that would give me minus 3 over 2. Now what happens now is we definitely get 2 separate answers. Now the reason being is because it was a positive number in here, because what a positive number does then is it then means that that will create a split, a divergence in our answers. So we end up with minus 2 plus 4 over 2, and then minus 2 minus 4 over 2. Now what happens then is that you get 2 separate answers. So what we can see then is that if D is greater than 0, we end up with 2 answers. And what do these answers represent? Again, they represent roots. So that might look like that, 2 different answers. Okay, now let's explore a third scenario in which this thing in here, which we're calling the discriminant, b squared minus 4ac, let's say that it now holds a negative value. So let's say it's less than 0. Okay, so let's plug in some random numbers here, but this one is going to be less than 0. Well, that means we would have, let's say, for example, it was minus 3. Okay, now we've got a slight problem here, which is we're going to try and take the square root of a negative number. Now we know that we can't do that. Or as far as we know, we can't do that. We can't take the square root of a negative number because that wouldn't give us a real answer. So what we could say then is that that results in an unreal answer. And that's because we've learned that you can't take the square root of a negative number. So what we say then is that gives us an answer which is not real or unreal. Okay, so that's 3 scenarios now. We've explored the scenario in which this thing called the discriminant is equal to 0. And when it's equal to 0, we found that we get the same answer. Okay. So, just one answer. We then looked at a scenario in which that number was greater than 0, and that meant that the plus or minus came into play, split things up, and we got 2 separate answers. And then, most recently, just up above, we looked at a scenario in which it was less than 0, and then that was meaning we're going to be taking the square root of a negative number. We know that that's not real, so what we say is that that gives me an unreal answer, or unreal answers. Okay, now we're going to take this stuff, which is our kind of starting point, but we're just going to formalise it a wee bit more. Okay, so we're going to use slightly more sound mathematical language, and this is what the exam would be looking for as well. So b squared minus 4ac, when that's equal to 0, what we say is that the roots, so that's your answers, remember that they're roots, that's these things. So what it says then is the roots are real. Now what we mean by that is you definitely get an answer from it, but what we found is when it was equal to 0, we get the same answer twice. So what we say is that the roots are real, so we get real answers, roots are real, and they're the same, so we call that roots are real and equal. Now let's just take a wee sketch as to what that might look like. We'll just means you get that one answer. So that might look like that. So that's what we want to sketch down. Okay, now let's envisage a scenario in which we've got the discriminant being greater than 0. Well, that means that we get two separate answers. So let's formalise that. What we'll say then is that the roots are real, and we're going to use a word distinct. Now, distinct means that they're completely separate, they're completely different roots. So we say that they're distinct, and that might look like that. So we can see there's one root and then a distinct other root. Okay, so we get two answers. We call that roots are real and distinct. Okay, then there was the final scenario in which this thing called the discriminant was less than 0. We then ended up getting the square root of a negative number, and we know that that's not real. So what we say then at that point is that the roots are non-real. Okay, and in terms of what that would look like then, that might look like this. So we're not cutting the x-axis at all. Okay, now we call this stuff the conditions of the discriminant.